This is Cold Start.
And today at Sonoma Raceway, it's NHRA weekend, so you might be hearing some low V8 grumbles going on and maybe some passes here later on. But today's topic of discussion probably isn't even out there at the dragway, or it'd be very uncommon for it to be there, especially during an NHRA weekend. But I thought it'd be fun to get down and dirty with the diesels for today's episode.
Diesel engines, we hear about those, and I don't know, we all have sort of a preconceived notion about what diesel means. I always think about cars that are made for efficiency first and foremost, not for performance. For a period of time, diesel fuel was cheaper than gasoline, although that's no longer the case. So diesel was sort of like the economic efficient answer to what car should I buy. And they seemed like they were really popular in Europe, and it took a while. They kind of lagged getting into the US. Mostly we see diesels on large machinery and big trucks and such. So why do we use diesel in passenger cars? Are there applications of diesel outside of that? There have been a few very famous and prominent diesels in motorsports. So we should dive into that and understand what are the dynamics of this thing? Why is this technology somehow different than gas engines? And what are the pros and cons to it? Why would you want this or not want this in your car?
Yeah, when I first think about diesel, like if anyone says like, oh, diesel vehicles, the first thing that comes to mind here in America especially is big pickup trucks. It's like, oh yeah, a Cummins diesel, a Power Stroke, a Duramax. That's when I think about diesels. And I usually think about trucks that are going to be towing stuff or towing trailers, or like diesel trucks are better at towing heavy loads. Right. And then thinking about semi-trucks obviously are diesels here in America. But that conversation that you're starting to think about, which is diesels in regards to passenger vehicles, I think is way more popular over in Europe. And I think the whole environmental, better fuel economy, that sort of deal is the main reason why that took off over in Europe. But it was weird. It was always so hard for them to become popular here in the US because I think a lot of people had that kind of idea that a diesel vehicle was like trucks, and diesel's dirty and black smoke and rolling coal and all that sort of stuff. And so people thought, oh, if I'm driving a diesel Volkswagen Jetta or Golf, that's weird, that's bizarre.
It tended to be those kind of vehicles too. Again, those sort of economy vehicles from Europe. VW is sort of right in the sweet spot of these things. And
for the good and the bad.
For the good and the bad, yeah. So those people you knew who were early adopters of having Volkswagens in the US, they were out there doing the diesel thing before everybody else. They were getting used to that. There were some other import cars too that were diesel-based far before there were a presence of those on the roads in the US. And over time, I guess people realized it was harder to find diesel fuel. You see it on the highway because the truckers are using it, but not every gas station has diesel. It seemed like a limitation or something that you'd have to have some benefit that was worth all of the extra overhead of dealing with this exception, this difference in your car.
Now that I think about it, in terms of diesel SUVs, diesel sedans, I can't think of too many right off the top of my head that's American made. All the diesels I can think of, SUVs, whatever, are all European, whether that's, diesel Mercedes, diesel Volkswagens, diesel BMWs. They're mainly European. Diesel Volvos, they're all going to be European made. I can't think of too many diesel passenger cars that come out of Asia, Japan, even America for the most part.
Yeah, there are no American passenger cars that are diesel currently on the market. There are trucks, right? You can find some GM trucks, some Chevy trucks, some Ford trucks, some Rams.
Just the pickups.
But just the pickups, right, that are made to effectively have that higher torque sort of configuration.
Yeah.
So we should talk about the sort of characteristics of diesel, which is why is it good in trucks but not so good in passenger cars? What's the difference between those? I would first guess, well, trucks are a lot heavier and maybe are hauling heavier loads. So does that have something to do with it?
Yeah, kind of now diving into more, what is the engineering benefits or downfalls behind a diesel engine? And in regards to their performance, we'll dive into the nitty and gritty of why these engines have these characteristics. But the main difference of a diesel engine versus a gas engine is torque numbers. Mm-hmm. We always talk about how much an insane amount of torque diesel engines can produce.
Right.
And so that addition of torque is really beneficial for towing, hauling, pulling, weight. And so you want torque rather than horsepower in that situation because you want to get that weight moving versus wanting the overall power and performance of horsepower. And so those are usually the main differences. We can get into like, why is torque a good thing in passenger cars? It makes it feel zippy, right? Like torque makes a car feel fast. It might not necessarily be fast, but it feels fast, a little bit quicker response when you're at speed to change speeds, things like that.
Yeah.
But that's the main reason why diesel engines are used in big trucks like that is for the torque numbers that they can produce.
So ultimately, that means there's more force to twist the drivetrain. So, like what's coming off the engine, you're turning a drivetrain, and more torque means more power to turn, not necessarily more speed to turn, right? So, acceleration happens by turning the drivetrain more quickly, but more power comes from turning the drivetrain with more force, which is what we call torque.
Yep, to get things moving, right? So, now why do diesel engines produce more torque than a gasoline engine?
Yeah, well, we're going to have to dig into the architecture of engines a little bit. And maybe this is primer or first time for some people. Maybe this is a reminder or refresher. But the kind of engine we have in most passenger cars, and we're going to sort of broad sweep across this because there are lots of exceptions, and we're not going to go into every exception. But by and large, road cars today use what's called the Otto cycle engine. That is an internal combustion engine that produces 4 phases in order to create power. So what happens is there's a spark, which creates a flame, and that flame is introduced into a chamber where there has been introduced fuel and air at 2 separate times. And then what happens is the spark combined with the fuel and air makes an explosion. That's the combustion. And then the final stage of that 4-stage process is the exhaust, taking the gases that have been created as a result of combustion out of that chamber. And this is effectively what we use to translate into power in an engine. So it's those 4 stages. We can think of that as a spark ignition. It is the spark, it's literally an electronic spark that's coming from a spark plug that makes the fuel and air together explode. Now, contrast this from a diesel engine. Diesel uses a 3-phase method of creating combustion. The fuel that's introduced is injected over a slightly longer period. So it's while the piston is moving down, we're injecting this fuel, and it keeps the pressure relatively steady. And what happens is the compression itself is what creates the ignition of the fuel that's in this area. So the pressure remains steady as it burns. This is a constant pressure heat addition versus an Otto engine in the 4 cycle where you have a constant volume heat addition. So it's just a different mechanism of exploding the fuel and the way by which we manage that process. And the result of that is different types of output, different types of power.
So a diesel engine, in that case, wouldn't have a spark plug.
Correct.
There's no ignition from a spark. The ignition for the combustion is happening from the compression.
That's right. There are no spark plugs in diesel engines.
So it kind of simplifies it, right? Of you're just compressing the fuel, creating energy, creating heat in it until it explodes, and then it drives the piston downward.
That's right. And so they operate at higher compression ratios by comparison to Otto engines. You know, most Otto engines, passenger cars that you think about, compression ratios are generally 8-to-1 to 12-to-1. You'll hear about most of the time. On a diesel, you'll see 15 to 22-to-1. So a lot higher compression ratio. And each of those strokes of the piston into the cylinder is longer. So the longer compression stroke is creating more torque per stroke.
Okay. Yeah. This is where the additional torque comes from in a diesel engine.
That's right. And then further, there is a higher energy density in diesel fuel compared to gasoline. It's about 10 to 15% more energy dense. So for the same amount of liquid that you burn, you get 10 to 15% more energy production in the same amount of fluid.
So then it would be more fuel efficient.
That's right. And then finally, there's less refining done to diesel fuel. So there's less energy spent, less refining effort to create the diesel versus gasoline. Although there's a flip side trade-off on that is what winds up burning is a little bit dirtier than what comes out of gasoline engines. So some of the downsides to these things, right? The diesel fuel itself is different. At cold temperatures, it can create this gel. They call it fuel gelling, where the fuel actually starts to solidify a little bit. And because of that higher level of soot and particulates that diesel engines generally create, we've created a number of methods and systems by which we try to manage the particulates coming out of the emissions on those cars. There's this system DEF, this thing that all the truckers hate, but it's this additive effectively that they put into the engine to try to allow the diesel engines to burn more cleanly. The cost of fuel these days is higher for diesel. That didn't used to be the case. Back when I was a little kid, I remember diesel was generally cheaper than gasoline.
Well, it would make sense that diesel would be cheaper because you're saying it's less refined. The
Right.
process is shorter. That means those companies should be spending less time and energy to create diesel. So it is very interesting nowadays that diesel would be more expensive than gasoline.
Yeah, and you think about the capacity of fuel in a truck or industrial vehicles, it's enormous. So to carry that much more fuel, if the fuel could be slightly more efficient and cheap, that would be a huge benefit. And we accept the trade-off that these vehicles, they make more particulate matter, they make more pollution.
I would say that another downside to diesels, and I guess this is more from like the infrastructure perspective, but every time I go to a gas station and I look at a diesel pump, it is significantly grosser in terms of just like its cleanliness comparative to a gas nozzle. And then also, like, if you start paying attention when you go to a fuel station that has gas and diesel, where all the diesel pumps are, there's usually like a circle of like oil stain of where the diesel pumps are comparative to the gas ones. Because like you're saying, because diesel is less refined, there is more of like an oiliness to it. And so like it kind of just gets everywhere. It's like a slime almost. And that also kind of leads into what you're talking about of like when temperatures start to drop.
Right.
And it's a little bit more viscous of a fuel comparative to gasoline. But I think that's another one of those downsides of like if I had a very nice European diesel SUV, sedan, station wagon, whatever it is, and it's like, ugh, I have to use those gross, dirty pumps that are at the gas station because I want to fill up with diesel. Like, that could be another downside to having a diesel.
Very much so. I think some of that is an artifact of how few of those vehicles exist here, and the ones that do exist are largely larger work trucks and industrial vehicles. So when they're coming into the gas station, maybe they're leaving a bit more mess behind, or, just the whole process of that is dirtier than just a small passenger car.
Right. Yeah. No, absolutely.
Yeah. And another cool attribute here, I guess there's a pro and a con to this, right? With the higher torque that you get out of a diesel engine due to that longer compression stroke, the higher compression in the engine creates more vibration. Or that's why when you're sitting in a truck that's a diesel engine, the thing vibrates, right? Like we haven't optimized these things purely for comfort and cabin noise the way we have with passenger cars and gasoline engines. They just shake and vibrate a lot just because that's the nature of those engines. And then those are usually heavier vehicles, and another downside that goes along with that is the acceleration. So acceleration in a diesel is generally slower than in a gasoline engine, partly because of those longer compression strokes and the nature of torque versus horsepower, how we're managing that here. So yeah, if you get in a diesel car and you floor it, you're probably going to be really underwhelmed with the acceleration of that vehicle. And I think that's one of the things that has caused people to steer away from them for passenger vehicles, as passenger cars have gotten so quick. So much of your driving is from a stop to a moderate speed back to a stop. That quick off-the-line acceleration feels so much more responsive from your car, where if you don't have that in a diesel, right, it just feels like you're sluggish and you're constantly holding up traffic or slow to get off the line.
I think another downside as to why diesels didn't really take off here in the States is, like you're saying, the additional vibration. And like a diesel engine is louder, it's noisier, it doesn't seem as refined and balanced as a gasoline engine.
Yeah.
And so like that's a downside, right? Is everyone always thinks about like having a diesel in their car, it's just going to make, the loud ticking and vibrations and stuff like that. It's not going to be, that smooth driving experience that we're so used to. And I think that's why a lot of consumers were always turned away from a diesel.
Yeah, that's right. And I think just the prevalence of those in Europe compared to the US made that more of an apparent option for those consumers. Whereas here in the market, you had to kind of do your research. It's like trying to buy a biodiesel car or a E85 car in the US. They exist, but you have to kind of go look for them. You have to research and figure out what your options are. Hydrogen cars are the same way, right? You want that Toyota Mirai, you got to go hunt for that thing. It's not just like on every lot.
Yeah, and then also like the addition of making it difficult to like go and buy a diesel car. I guess especially in the U.S., but I think the U.S. and Europe are pretty much the same in regards to their vehicle emissions restrictions. And like you're talking about, like Diesel engines themselves are very robust and they're very reliable. Not a lot of things go wrong with diesels, but where the added complexity comes in that might cause for really expensive repair costs with a diesel motor is all of the emission systems. It's everything to basically prevent the way that they burn fuel, the way that they burn diesel is pretty crude, and the stuff that comes out of the tailpipe is pretty gnarly. And so these emission systems have to be so much more extreme in comparison to a normal petrol combustion engine to be able to prevent those particulates to go out into the environment. And so that means that like if you have an issue with your emission system, like it can shut down the motor, it can put it into limp mode. I mean, we know this pain of even just with gasoline motors of like O2 sensors and things like that that drive us crazy, or catalytic converters. And with a diesel, it's just so much more. And like that DEF system that you're talking about, now we have this additional system that's involved with the engine that provides no performance or reliability, but its sole purpose is just for emissions. And if that system fails, once again, it throws a bunch of error codes, not to mention that this DEF fluid, which is a legitimate fluid, you have to purchase this every once in a while to put it in your system. It basically just sprays the particulate, the exhaust that's coming out of the engine to make sure that it kind of like solidifies or it doesn't go into the environment. Like that's the point of DEF fluid, is like essentially like a sprayer to like allow this stuff to not go into the environment. It's pretty crazy, all of the emission systems that go into diesels. And a lot of those systems are what kind of quote unquote chokes the motor to where like it's not able to perform to its peak efficiency, but to its peak environmental efficiency.
And to the point where the US and Europe are relatively well aligned on emissions requirements and standards these days. In the US, there's basically no passenger cars that you can get with diesel anymore because the emissions requirements have become so stringent that just nobody's invested the time and energy to make the complexity necessary in diesel cars when it's known and done in gasoline cars. And now we're introducing EVs, where this is sort of an inherent product to the cars that there aren't emissions in that way. So over in Europe, however, with this sort of shift that's currently occurring in the EV market, like we just talked about in our most recent episode, there are actually cars being manufactured in Europe and by European and Asian manufacturers that are diesels these days. Stellantis is sort of reversing from their EV-only strategy, and they're reintroducing a few diesel options like the Peugeot 308 and Opel Astra, even the Alfa Romeo Giulia and Stelvio. They're going to offer diesel variants of those. BMW and Mercedes are continuing to make mostly their SUVs, but there's also a Mercedes S-Class variant in Europe that's available with a diesel. So those do exist in Europe, and I think we're going to be in this transition period for a little while we're settling the dust on the EV argument, whether or not diesel has any chance of making a resurgence. In the US, I think it's unlikely given the cost, the sort of history, and the sort of, I don't know, the inherent incumbency of gasoline in the US compared to diesel. Diesel was always such an exception, whereas much more accepted. And in the infrastructure in Europe, I think it's probably seen its last days in passenger cars, and it will remain relegated to heavy trucks and industrial uses.
Yeah, I think it's going to be really tough for diesel to make a comeback with passenger cars because we have so many of these alternative methods of fuel with electric, hybrids, all that sort of stuff. And the only leg that diesel had to stand on for a long time was that diesel was less expensive than gasoline. Well, now if diesel is even more expensive, even though you can get better fuel economy with a diesel engine, the numbers might not math out to make it beneficial.
Yeah, and there are alternatives, right? People do this biodiesel thing. There's hydro-treated vegetable oil that is compatible with certain types of diesel engines. There's other renewable alternatives that are out there. But in Europe, they do have a few other restrictions. They have something called low-emission zones. So older diesels are actually banned from city centers in certain cities like Paris and Madrid and London. So with the tightening of emissions requirements over time, even that existing incumbency of diesel is finding limitations for where those can be used.
And funny you bring up the restrictions once again, because it's like this whole conversation of like one of the main downsides of diesels, in my opinion, is all of these emission systems that get tacked onto them, and that's the added complexity that make them suck. And if we talk to a pickup truck fan here in America, they would tell you everything about like, oh, well, back in 2008, the diesel pickups comparative to them now and making all these transitions with the emission systems. Now they don't run worth a shit, all that sort of stuff. But talking again about, Europe being super restrictive on diesel usage and that sort of deal, the manufacturers, even at one point, found it very difficult to keep the cars within compliance for emissions in regards to their diesel vehicles. Mainly, Volkswagen was the one that got caught.
It's not like they would cheat at this, right? I mean, they would lie about how they were doing their emissions. I mean, there's testing, right?
Yeah, the testing, obviously cars have to go through testing for the government regulations to make sure that they're emitting the things that the manufacturers are saying they're emitting and they're fitting within the portfolio and all that sort of stuff. But there was a huge scandal that happened that Volkswagen basically coded their cars that they would recognize that they were being tested and they would run differently for those tests to be within compliance.
Yeah.
And then when the car would detect that it's back on the road again, just normal driving, it would switch the maps and it would run a lot less clean, but it would give the consumers better fuel economy, better performance, and make the diesel engine run how it wants to run, but be polluting the environment a little bit more. Now, Volkswagen was the one that got caught, but I know that there was other German manufacturers that didn't admit that they did exactly the same thing, but they didn't say that they didn't do the same thing. I think Volkswagen was the scapegoat for everyone else because, once again, these diesel engines, they can run really efficiently and they can burn fuel really efficiently, get really good fuel economy, and they can have great performance. But as soon as we add these emission systems to them, it kills the motor. It makes them unsellable in a sense. And Volkswagen was a part of that huge Dieselgate scandal.
And it's one of those things you figure like, oh, this is some weird little niche part of the automotive industry. It couldn't have really affected that many people. 11 million vehicles, and that's Volkswagen alone, that were produced that had this software defeat device eventually that would make it pass the lab tests but pollute. I think the stat was it emitted nitrogen oxide, which NOx, which is one of the pollutants that we monitor, at around 40 times the legal limit.
When it was on the road?
When it was on the road. And they were fined, they got in trouble, and they've paid now over $30 billion in fines.
And I think they had to buy back every diesel car too. Like they had to give the consumers, the owners, the option of like, hey, we'll buy back your car for whatever you paid for it.
Right.
And like owners could opt out and be like, no, I'm going to keep my car. I like it. I enjoy it. It's fine.
Mm-hmm.
But there was a lot of those diesel cars that got basically taken back by the manufacturer. I think just parked effectively, crushed. They were obsolete. They couldn't run anymore. Even if Volkswagen was like, all right, let's rewrite the code. And it's like, no, you're done. These things are parked.
These things are going to be taken off the road, and they're a representation now of your failure as a company. And it's a huge black eye for Volkswagen, the people's car. That's how this thing started out. I mean, there's other unpleasantness in the history of Volkswagen that we don't need to go into. But the whole positioning of this car, it's something hippies love. It's for the people. They're cheap. You can, interchange the parts. They were air-cooled for a good long time. And then we think about this company's the one that's actually cheating in the emissions test.
It's pretty funny. Yeah. Well, so we've talked a lot about diesel engines, why they're different than gasoline, pros, cons, the general consumer vehicles, why diesel isn't really super prevalent in consumer cars in America. But let's talk about some cool diesels, because manufacturers have created some interesting diesels in the past, and then we'll dive into the motorsports aspect of diesel race cars.
Right.
Is that a thing? Was it a thing? Where is it a thing? That sort of deal.
And there's some intersection there. So if we start with just production cars, what's a cool way to make any car a little bit cooler? You put a gnarly engine in it, like a V12.
More cylinders.
More cylinders. So at one point, Audi made a 6-liter V12 TDI. They made it from 2008 till 2012. It was the only V12 diesel engine ever put into a production passenger car, except for the Audi Q7 SUV, which had the same engine. And in that car, it produced about 500 horsepower and over 1,000 Newton meters of torque. So the thing could twist.
What production car did they put this thing in?
The Audi Q7 SUV and the Audi V12 TDI SUV. I'm not sure which model that was.
So they were both for SUVs?
Yes.
Okay. I mean, that's a pretty sick engine to have. I think they used it in the Touareg as well. There was a Touareg V12 TDI.
The VW Touareg, when it came out, that was 2004 to 2008. And well known as like way over-engineered as a car, it was the basis for the Cayenne and the other variants as well.
Uh-huh.
They made a 5-liter twin-turbo diesel V10 configuration.
Oh, okay. So they saved the V12 for the Audi.
Yes.
So you had to up-badge yourself into Audi versus Volkswagen.
But V10, pretty sick, right? And of course,
super cool.
V10, they're well known in the Audi world for having done that with the R8.
Which, speaking of the R8, there was a concept car that they put the V12 TDI engine into an R8.
Oh, sick.
And that was like, they only made one of them. It was a concept car. It never went anywhere. But they were kind of starting to think about this like diesel sports car to try to like bring that to market, which this engine, them creating a V12 TDI, the V10 TDI, that was kind of intertwining with their motorsport efforts at the time, right?
Totally, yeah. In the early 2000s, Audi was super dominant in WEC and all the Le Mans series with their cars. It was the Audi R10 TDI, again, V12, that we saw enter into that series and had a lot of success, to the point where even another manufacturer decided to get on board too. So Peugeot put out their 908 HDI V12, which was a diesel car. So one begot another one because they saw the tremendous capability and advantage that the Audi car had, partly due to fuel efficiency. Imagine you're running the 24-hour Le Mans and you can save 1 or 2 pit stops, okay?
Which would be massive.
Massive change. And only that difference, even if your car was equally performant to the others, even a little less. If you didn't have to make a couple pit stops that the other teams had to make because your fuel was just more efficient, hey, that's a huge win. So that's what they did.
So, I mean, like, diesel engines can be used for performance applications. I mean, I know we talked about, like, oh, diesel engines are really just for trucks and hauling big loads and this, that, the other. But, like, for diesel engines, like, they can be performance engines and they could be used in a motorsport aspect. I think the only reason why they didn't put it into the R8, which, like, buying a diesel R8 would have been a wild concept.
Yeah.
But I think the only reason why they didn't bring that car to production was because of the additional weight of the engine, that they could have made it a lot lighter if it was just a V10 gasoline engine, which makes more sense for a sports car.
Yeah,
and
for
I think
SUVs, nobody cares about the weight penalty.
Right. That's why the V12 ended up in the Q7, because it's like, yeah, it already weighs a lot. What does it matter if it weighs a little bit more?
Since the Europeans were already way more into diesel to start, they were finding motorsports applications for it. So in the WTCC, the World Touring Car Championship, we saw the Seat Leon TDI.
That's funny.
Successful for a couple of years. So yeah, another not V12, but actually a 6-cylinder diesel car that was really successful in motorsports.
I think there was a single make series that Volkswagen put on, and it was the Volkswagen Jetta TDI Cup.
Oh, single make.
Single make series, all diesel. And I think there were some special edition Volkswagen Jetta TDIs that you could buy that were like the Cup model because of the race series that they were putting on. The only reason why I know like a smidge that this series even existed is because there's a car in iRacing, and it's the TDI Cup.
Sick.
So I think it existed as a series as well for them to be like Volkswagen promoting their diesel cars and being like, hey, diesel can be fun. It can be performance oriented as well as being really, really fuel efficient.
Yeah.
And I also remember, speaking about Volkswagen and diesels and performance cars, when I was over in Europe, this was back when I was really into Volkswagens and loved GTIs, but they developed a Golf that was the GDI.
Oh, my.
So it was the performance diesel variant of the Golf. So rather than the GTI was the gasoline internal combustion, the normal car that we all know about, which the GTIs always had like the red stripes on the front to distinguish them. The GDIs, it was a green stripe.
Oh, because it's more efficient and earth-friendly somehow, maybe?
Earth-friendly, it's green.
Yeah, yeah. Well, I guess I misspoke earlier that Seat Leon was a 4-cylinder diesel, not a 6. But either way, commuter box car that people used in Europe that they said, this would be really fun to go race.
But yeah, it's kind of cool that like finding diesel engines in motorsports, I feel like they're hard to find. I think the Audis are probably the most famous that went off and did the 24 Hours of Le Mans.
If you go way back, though, in 1950, in the Indy 500, we had a Cummins diesel engine car as an entrance, and it had a turbo.
Of course it has to have a turbo. I don't know a diesel engine that's NA that's going to have any sort of performance potential.
Well, can you explain that?
Well, so for the diesel engines, obviously they can take a lot more fuel. Like you can dump a bunch of fuel into them.
Yep.
But their main problem is their fuel to air mixture. And so the biggest thing with diesel engines is they get starved of air. So you can have the capacity, because you have these big cylinders, right? You have the capacity to jam a bunch of fuel, throw a bunch of diesel in it, but if you can't keep up with the air, you can't have the additional performance.
Right.
So once again, air, fuel, you got to make sure that those things match up. And that's why diesel engines are super useful with turbos, is because the turbos can start jamming in more air. And then also with a diesel engine, they produce a lot of exhaust gas, which can help feed the turbo, which then can help feed more air back into the diesel engine. And so turbos on diesels, super necessary to develop that additional performance.
Yeah, they seem really well paired. And in particular, if you add the characteristic that their acceleration tends to be kind of slow. So when you lack a little low down power, but once you're in the power band, the torque will kind of help get you some acceleration, that offsets, right, that disadvantage. So by having a turbo, to the extent that that turbo gets spooling up and spinning at a rate that's more quickly than you're going to be able to get power out of your engine, it helps with some of that lacking acceleration that you'd otherwise have.
So this Cummins diesel turbo-powered 1950s
The green
Indy car,
the Green Hornet.
how'd it do?
Well, it shocked the racing world with its engineering and performance. So we talked about engines running a little more dirty with diesel, right? So the car did well in quali, and it was fuel efficient, so it looked like it had the advantage from that perspective. We talked about pit stops. They actually earned the pole position for the 1952 race, but they also in 1952 failed to finish the race because of a clogged turbocharger inlet that was caused by debris. So whether that's specifically because of diesel or not is not totally clear, but gives you an idea. So they ran in 1950 the Green Hornet, and then what they called a lay-down race car in 52, which was the first turbocharged vehicle to race at Indy.
Oh, wow. Interesting.
And that's the Cummins diesel special, that there was a 401 cubic inch, so that's like 6.5 liter Cummins engine.
Nice.
It was an inline six, and because they wanted to lower the car's center of gravity, they rotated the engine on its side, and that's what they call a lay-down configuration.
Wow.
And so they had a crankshaft-driven turbo, so the engine was able to put out about 400 to 430 horsepower back in 1952.
Which is pretty solid.
Pretty impressive. And yeah, they managed a quali lap at 139 miles per hour and landed the pole for that race. Pretty impressive. So if they would have figured out their particulate debris issue in their turbos, potentially they could have taken it.
Needed a little bit of a filter there on the inlet side of it, but
yeah,
interesting. I think that was the only diesel to ever run at Indy. I would imagine that's the only time. Like, it was kind of like back in the day when you could get away with being innovative at the Indy 500.
Yeah, in modern era, right? It looks like there were some early attempts that might not have gotten out of the gate exactly, but it was this one in 1952 that they really consider to be the first full entry into the Indy 500 that was a diesel.
So in other places in motorsport that I've seen diesels, or at least like there's been this big conversation about diesel performance and like competing in the diesel category, is Pikes Peak. And now, once again, beyond Le Mans, like that's the only time I've ever really like seen performance diesels competing. And with the Pikes Peak hill climb, we know that they're super inviting to the weird, the bizarre. And so in regards to hill climb records for Pikes Peak, the fuel you're using is a category that you can go after that record, whether that's
Interesting.
Gas, electric, hybrid, propane, diesel, whatever, right?
Oh, I guess that makes sense, though, because the characteristics of how all those different fuel types combust or turn fuel into energy is going to be massively different at altitude.
Yeah, which is interesting. Of each one of them deals with altitude differently.
Mm-hmm.
And I feel like gasoline is kind of like middle ground, right?
Yeah.
Where electric is the most beneficial because it doesn't get affected by altitude. Electric vehicles will perform the same at sea level as they do at 14,000 feet.
Modulo temperature, right?
Right.
Yeah.
And as long as you can keep the batteries cool, you should be able to have the same performance. But this conversation about diesel, which I never really like thought about, that like diesel engines are more susceptible, I would say more susceptible to altitude than a gasoline engine, which makes them more challenging to run in competition at Pikes Peak.
So that thinner air that's being forced into the cylinder in a diesel engine isn't creating as much of a combustion. What is the difference there exactly?
So the lack of oxygen at altitude is going to make it more difficult for the diesel engine to keep up in its oxygen intake to combine with the fuel to make the explosion.
So you wind up being lean on air,
which is rich.
The
engine starts running rich because you're overfueling the engine.
Because the air that it's getting is insufficiently oxygenated.
Right. And even with turbos, which that's why turbos are so great for diesels, is it allows it to compress the air into the engine, which a diesel engine relies on compression to be able to combust.
That makes total sense.
And so if it doesn't have that right amount of air, it basically just starts dumping the fuel out the exhaust. So if you start overfueling, this is why if you see a diesel truck flooring it, that like if it starts getting up to like overperforming and it starts dumping more fuel, that's why you get like the quote unquote roll coal, where like basically all the black smoke comes out the tailpipe.
Oh yeah.
That's all unburnt fuel basically is what's happening, is it's getting dumped. So the car's not able, or the truck's not able to keep up with an air intake to match the fuel that's being dumped. So like, and I'm not going to get into the specifics because I'm not a diesel guy, I'm not a diesel fitter, and I don't know too much, but like basically if you upgrade your diesel and you put in like better injectors that can dump more fuel, but you don't do anything to help match the tune to be able to get more air in, it actually starts harming your engine. And with diesels, the biggest thing that's the threat to the motor is your EGTs, which is something that we do not talk about in regards to gasoline engines. So your EGTs, which is your exhaust gas temperatures, can start to increase if you have insufficient air. So if you're starving the engine, overloading it, overfueling the motor, and not matching it with the air, your exhaust gas temperatures start to rise. And this is where we can start to melt things and things start to deform. And obviously these exhaust gases are also going to be fed into the turbos, which are spinning up to be able to take the intake air to compress it. And so if your EGTs are leaving the engine, your exhaust gases are leaving the engine too hot and then feeding into your turbo, you'll start to overheat your turbo and you can melt the turbo down.
It sounds like there's a lot of disadvantages to this. Why would people run diesels up the hill?
To go after the record, of course, right?
The diesel record.
Yes. So it's like making a diesel Pikes Peak car isn't going to be the fastest thing up the mountain.
Right.
But it's just dealing with that new challenge, right? Of going after that record because it's challenging. It's hard to make a diesel engine survive up Pikes Peak for multiple reasons. One is just altitude in general, right? It's difficult. The other thing with diesel engines is they don't like to be kind of under heavy load for a long period of time, because that's what can start to build those EGTs as well, even if you're at sea level. If you think about like going up a steady grade, you're constant throttle, you're putting load on the engine. And so if you're going up a steep grade in a diesel engine, you have to be cognizant of where your gearing is and where the EGTs are, and you have to manage the engine temperatures in that regard. Pikes Peak is one big grade. You're just going uphill the entire time.
Oh, yeah.
And so you're putting all of this load on the engine. You're having to dump a bunch of fuel to try to make power, to try to keep the car in the power band. But in doing that and over dumping fuel, you can create these additional temperatures that can cause failure. So you're trying to build up the engine to make a lot of power to be competitive, but in doing that, adding more boost, adding more compression, adding more to the engine, you're also bringing it closer to the brink of just total implosion.
Gotcha.
And so running diesels is very challenging. And like the individuals that I've known that have run diesel vehicles at Pikes Peak have a lot of mechanical failures. Like it is hard to keep the engine together, even though the run itself is only 10 to 11 minutes. It's hard to manage the heat in a diesel engine comparative to an internal combustion engine.
And if you look at the lap time differences, they're significant, right? So we're not just talking about a few tenths here or a couple seconds difference. Like the difference between the gasoline combustion engine record for getting up Pikes Peak and for diesel is over 2 minutes.
Oh, it's massive. It's huge. And so, yeah, the diesel records, I think the first diesel record that I know of that happened at Pikes Peak was Mercedes. And Mercedes brought basically a production car.
Right.
It was like their sedan, their diesel sedan at the time. And the record that they were able to set was, I think it was like an 11-minute, 37-second run.
Which seems slow.
Which at Pikes Peak isn't like a blistering time by any regards.
Right, like 10 minutes is sort of the benchmark. Like if you're under 10 minutes, like that's respectable and fast.
Yeah, I mean the overall record, which is electric, is sub 8 minutes.
Oh my.
So like we're talking about this massive gap. And so that record was set back in 2015. Now that record stood for diesel until 2020. So even though that time doesn't sound like it was that fast, it took an additional 5 years for that record to be broken again, which local infamous motorsports racer, Pikes Peaker, Scott Birdsall, who has his shop here just north of Sonoma Raceway in Santa Rosa, he was the one that was able to break the record, break Mercedes' record in 2020 in his heavily modified, Cummins-powered Ford F1 diesel pickup.
So we're talking like a 1950s chassis?
Yes, with patina and a massive rear wing and a huge engine.
Sick.
And so in 2020, he was able to reset the diesel record at 11 minutes, 24 seconds.
Okay, so he was able to beat by only a couple seconds that Mercedes, the C250D.
Yeah, just over 10 seconds he was able to slim off it. And ever since then, he's been trying to rebeat his record. And so with the truck's name is Old Smoky. So he was trying to go after the diesel record with Old Smoky for a handful of years after that, whether it was because of issues with the truck or weather on the mountain, wasn't able to better his time. And then he also started to build like a low slung prototype that was going to have a diesel engine in it, but he kept having issues with the motor and that to be able to keep it cool or whatever it was,
Maybe
the engine was having issues.
Taking inspiration from that Audi LMP1 car.
Yes. Which like that, I think that would be like a perfect example of, a diesel performance car. That's the sort of thing you want to bring to Pikes Peak.
Yeah. But the overall diesel record is by some contraption that was built, right? It was like a Radical that they did an engine swap with some kind of Volkswagen diesel, and it was like a tri-turbo, some kind of crazy config.
Yeah, so 2023 was basically the Pikes Peak diesel off. And there was 3 main competitors that were going to come to Pikes Peak in 2023 to go after this new diesel record that Scott set 3 years prior.
And what a weird time, like diesel having this resurgence at a time where in the industry it's basically vanishing.
Right. And I think that's what's kind of cool is like, I feel like the diesel category at Pikes Peak was one of those things that was kind of like forgotten about for the most part. And then, it allowed that these individuals could be creative to go after this record of like, no one was kind of paying attention to the diesel record. But then for whatever reason in 2023, there was like 3 main players that came. And once again, Scotty was trying to bring this new prototype that he was developing with the diesel engine in it. It had issues before that year's event. And so he had to bring the pickup truck again. And so he brought back Old Smoky. He was going to run Old Smoky. There was another individual, Powell. He was going to be running a diesel-powered Nissan GTR.
Sick.
Which is sick. I mean, like a diesel swapped anything is kind of sick because it's like, this shouldn't exist, right?
Right.
And then the third player in this game was a diesel-powered Radical.
Interesting. So as somebody who drives a Radical, I'm trying to get my head around that. It usually has a Suzuki Hayabusa engine in it.
Yeah. So it was the Radical SR chassis. It had a Volkswagen TDI motor in it, which was heavily modified. It had 3 turbos on it, which I can't even begin to explain how that engineering works of 3 turbos on a diesel engine, but evidently it worked. But Powell in the GTR was able to break Scotty's record, and I think he did like an 11.0 something. And so he was able to beat the record by 20-ish seconds. And then French. I'm terrible at French. Blachon.
Grégoire Blachon.
See, I didn't want to do like the fake French accent. You do it far better than I do.
Oh, thank you so much.
But he smashed the record by doing a 10-minute, 25-second. And Scotty, for that year, I think he was the last competitor to go up the mountain. And once again, he's chasing after this record. Gregory smashed it. He's like, all right, I got to like hold my crown or try to as the diesel record. And 2023 was the year that he sent Old Smoky off the side of the mountain.
Oof. Yeah, I saw pictures of aftermath.
Right, which he was okay, right? He was totally fine, was able to get out of the truck unscathed. But that was kind of like this big like head-to-head diesel battle that happened at Pikes Peak of all these 3 players. And Gregory wanted the diesel record super bad because the overall record is held by a Frenchman at Pikes Peak, which is the overall record is also the electric record, which is Romain Dumont. And then the internal combustion record is also held by a Frenchman, which is Sebastian Loeb.
Oh, yeah.
And so the final major power record or like fuel record was the diesel. And so he wanted to win the diesel record so that the French have all three.
Interesting.
Which there was a lot of like online bickering between Scotty and Gregory because it was like the French versus the American.
Right.
Anyway, there was a really great like lead up to this whole thing that happened in 2023, but now that's their new record at Pikes Peak is the 1025.
It looks like Gregory in the prior year in 2024 ran this classic VW Bug with a giant wing on the back as his entry into Pikes Peak. So he's out there trying different things.
He likes the eclectic stuff,
Yeah.
for sure. So he was an interesting dude. I was actually able to meet him, and like this whole concept of putting a diesel engine in like a low slung prototype, lightweight, it makes sense, right?
Yeah.
Rather than trying to go after like the big engines, the big diesel engines that come out of pickup trucks or Freightliners or whatever,
Right.
try to find something small that's relatively lightweight. And I mean, this whole conversation, right? I like Pikes Peak. Pikes Peak is sick. It's fun to go after records. But this whole conversation about, the diesel record at Pikes Peak made me think of like, maybe this is something to go after. Maybe there's some potential here to try to smash the 1025 diesel record in something, in a nameplate that's close to my heart.
It's interesting because it's very narrow area where they give you all the constraints up front. Like you have to use this kind of engine. So now that's going to pretty much limit the things that you can do, or it's going to suggest the design and the kind of choices you make. So it constrains the problem in a really interesting way. But then if you can be successful in that limited field, hey, like you can be the fastest in the class of this interesting variant.
Yeah, try to figure out how to win diesel. Which, speaking of the diesel, one last thing. Scotty, this past year at Pikes Peak, he ran a diesel-swapped Trans Am car. So Scotty's all about the diesels, right? He's never going to not run a diesel up Pikes Peak. So this new car that he had, it was a Trans Am, effectively a Trans Am TA2 chassis. It was a Camaro. And he swapped in this performance diesel engine, which competed in some other series, which I forget what series it came from. But he was able to borrow this engine, swap it into the Trans Am, and run it up Pikes Peak, which on the door above like the driver's name, he was Cole Trickle. But instead of Cole, it was Coal.
Oh, no way.
Cole Trickle.
That's too good. That's too good.
Anyway, so I feel like the diesel guys are having a lot of fun at Pikes Peak because it's like, it is this weird one-off thing. And like diesel engines are challenging to deal with and challenging to manage, trying to get power out of them without straining them too much. Heat in a diesel engine is a very hard thing to manage, and the cooling, especially if you run big turbos. And so all of that just makes it really, really challenging to go at Pikes Peak with.
Yeah, it's really interesting because it's this narrow niche of all engines that are made. It's a niche event as it is climbing up the mountain. So there are interesting variations on how people choose to do that. And I guess diesel is just another one. We have open wheel as a category. We have
Right.
electric as a category. So why shouldn't a different type of fuel? I mean, EVs versus gasoline, those are just different types of drivetrain, just different types of fuel that are making those cars go. So why not? Diesel seems just as valid as anything else to compete in motorsports or on the public roads too. Why not?
Yeah, no, absolutely. And speaking of that, kind of like the final note here of like, is there really like a diesel tuner culture in America? And I would say like not really, right? Like people tune their pickup trucks that have diesel engines and they can make a lot of power, like really, really impressive numbers. But in terms of like cars and sports cars, like they still really haven't taken off. But there is this one little secret, this one car that does exist that I think is starting to gain some traction for its tunability and its performance potential for not a lot of money.
So listen up if you want to be on the ground floor of the next new enthusiast car, tuner car that everybody's going to be out there looking for and the price is going to go through the roof in the next year.
I think it's going to happen. I think people are going to realize how phenomenal this car is. And it's mainly because of the engine that comes inside of it. And this engine is renowned around the world of being this phenomenally performing diesel engine that you can unlock an absurd amount of power for like no money. And so of the E90 chassis of the 3 Series, which
I knew it was going to be a BMW.
of course it's got to be a BMW. But basically from like 2008 to 2013, that's like the generation. The 335D, D standing for diesel powered. So we're not talking about the 335i.
I had
or
one
the
of those.
335IS,
Yeah.
right? That had the N54 with the twin turbo inline 6. Arguably a great engine, arguably a terrible engine. We don't need to get in that conversation. But the 335D of the same generation comes with the M57, the world-renowned M57 engine. And so this is a straight six diesel engine with turbos. Now, in its stock form, it's nothing impressive. However, if you delete all of the emission systems, if you remove all of the environmental emission things off of this engine and you put on a base tune, they're fast. Like, not ungodly fast, not like take down a Supra fast, but we're talking like 400, 500 horsepower from a stock engine, just removing things and tuning it.
And from a stock 335 that out of the box produced somewhere in the mid 300s of horsepower, right? So
massive increase.
Huge increase. And for something that was not all that sought out, there probably aren't that many of them in the U.S. Again, diesels being less popular.
Right.
This is yet another recipe for the next collector enthusiast car, right? They didn't make many of them. They were a weird variant. They're hard to find, but they have this untapped potential that we're now just realizing.
Which the M57 as an engine has become incredibly popular in the off-road community for people making like rock crawlers, overlanders, things like, especially in Toyotas, right? Of like creating these overlanders or whatever. And like every Toyota fan complains that they never got the diesel variant of the Land Cruiser or the whatever because the rest of the world did, but we never did here in America. But people are starting to swap these M57s into a lot of stuff because of their untapped potential and performance. And so like, I think the 335D is mainly going to be sought after because that's the only car in America that we got the M57.
That's really interesting.
Yeah, I mean, this has been a fun dive into diesels, which I feel like for most us car enthusiasts isn't like the first thing we think about, but they've been applied in interesting ways through motorsports and in some fun capacities as well.
And if you didn't pay attention to it back in the early 2000s when Audi was so dominant in LMP1, they were driving those TDI cars. Go and check those out. They're super cool.
Well, thanks, Todd.
Thanks, Silas.
And thanks for listening. This has been Cold Start.